Yeah, fragment which sets PA4 high, delays the MPU exactly half a second. The 1048576 Hz external oscillator and sets PA4 low, delays another half a second and repeats using only instruction delays, use subroutines. Okay, now let's go and see this. So here they have mentioned that 1048576 Hz is the external oscillator. It means this is extra, that extra is equal to 104,857 hertz. But here, in order to solve this one, we have to find out the internal clock. There's a relationship between internal clock and the external oscillator that comes like that is like 1 over 4 of the extra, like E clock is 1 over 4 of the extra. If you apply that formula, so this is going to be extra divided by 4. That one is 1 over 104,857 divided by 4. That is equivalent to 262,144 cycles per second. And based on the question, we had to do it for half a second. We had to divide this one by half as well. 131,072 cycles per half second. Okay, now we know that what is the desired cycle we need to derive. Based on that, we can go ahead and write our codes. Okay, and also here they have mentioned use subroutines. So it means we had to use these instructions, subroutine instructions, branch to subroutine, and that is BSR, jump to subroutine JSR, return from subroutine RTS. So we had to use them like you can either use BSR or JSR. Both of them does the same thing. Okay, and we had to use an RTS at the end. Okay, that's it. Let's go ahead and write out first. Write the start here, and we have to set PA for high and PA for low. PA for high is 16, PA for low is 0. So to set the PA for high, I load accumulator A, LDA, and here I'm gonna load 16 for it. You can load it in binary or hexadecimal. In binary 60, if you want to load 60, you have to put a percentage sign for the binary, and then 0 0 0 1 0 0. Because we are loading in accumulator A, it loads, you can use 8-bit at a time. So here this one represents 16, and in binary that's 8-bit digits. But if you want to load it in hexadecimal, you use this sign, hexadecimal, so 1, actually 10 for 60, the same thing. Now we store this one in accumulator, store in accumulator A, port A, then jump to subroutine delay, the name we are gonna give for the subroutine. Then LDA, now we are setting the PA for low, that's 0. Okay, it's 8 bits and it's 2 digits in hexadecimal is because of the hexadecimal represents 4 bits. But in binary, each STA jump to subroutine PRA branch dot. Okay, and to achieve the delay, we are gonna create a loop for it. I start X, and here we have to decide how many number of we are loading X with a number, so we have to decide what number to load with because we have to do a calculation to do that. So loading that one alone gonna take 3 cycles. Okay, then we have to create a loop for it. Let's name the loop as delay loop. You can name it if you want. Loop. And here we are gonna to make the loop run, we are gonna do the decrement of index register X. That one gonna take 3 cycles. Okay, and once the X, whatever the value we put X, for example, if I put 5 here, this is gonna run 5 times, and then it's gonna become 0 because it's decreasing each time. So when it's 0, it has to exit the loop. In order to do that, the BNE, that is when branch not equal to 0, it's going to keep on looping. When branch is equal to 0, it's going to exit the loop. When branch not equal to 0, it's going to go back to delay loop, that is this. That takes 3 cycles. And finally, we are going to look at this. Art is returned from subroutine. It's RTS. That one takes 5 cycles. Okay, so now what's going to happen is, we are setting PA4 high, PA4 low, and then it goes to the subroutine. Then here we have a loading an X value with something. Then it's going to enter the loop. And based on the value we load for the X, it's going to run that many times. And these are the two things that's going to keep on running. Okay, these are the two things that's going to use a different color. Just to put in the code. Okay, so these two other things keep on running. Okay, depends on what value I put for the X. And this only runs once, like once it load X and then enter the loop, and it keep on repeating again and again and again, depends on the X value. And then after it reaches 0, it exit and go to the RTS. So this one only happened once, this one also only happened once, this one gonna happen depends on whatever the value we put for the X. So in order to calculate what to put here, we have to look at what we need to achieve. So here our desired number of cycle is 131,072. So this 3 and this 5 will be, this should be eliminated, not calculate this one because these are just happening one time. So 3 plus 5, then plus we have to have a value. Let's say I want to figure out what is the X value. That one currently runs 3 plus 3, and that should be equal to 131,007. So we have to figure out what's the x value we have to put in order to run derive this one. And let's say if you are getting an x value that is a fractional value, then you have to do something like there are some extra things you can do. You can do nope, that takes extra 2 cycles. There are some other things, but first we have to decide like, is this good enough or do I have to add some extra? It's good enough if we don't get a fraction for the x value. So here if I solve for this, it's going to be x times 6 is equal to 131,072 minus 8. That's going to be 131,064. Okay, and then to find out x, I divide this by 6. 131,000 divided by 6. Let's use a calculator. 131,000 divided by 6. That's give me 21,844. So since I'm getting the whole number, I don't need to actually put anything extra here in order to, make more cycles, because this is good enough to make that work. And we are trying to keep the code as short as possible. Okay, and to mention this is, we are just putting the number, we put a ampersand sign like this, because if you don't put it, it means it directs to the address, and that's going to be a different story. So we don't want that to happen. We just put a number sign to make sure this is a decimal number, and that is 21,844. And now if you plug that one in this equation, you should get this back. Okay, if you plug this value, you should get this one. So this loop is going to run this many times, and each time going to take 6 cycles for each time. That's why we multiply by this, and then this only happens once. Okay, that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.